Okay, it's time for yet another MacBook board repair. Let's have a look at this poor MacBook Air under the microscope. We can clearly see it has some liquid damage. Looks pretty nasty actually. This is one of those boards that's just corroded from everywhere. You can see there's corrosion by our CPU and by our CPU MOSFETs, which is very sad because this may have a dead CPU. Okay, the board's out. Let's have a look. So we see some signs of liquid. That's expected because something was spilled on it. We have some under the SMC. SMC should be fine. Some near the backlight driver, so that has to go as well. So this looks like it's going to be a fairly intensive board repair. A little corrosion on the cap, that has to go. The main area of concern is going to be this, because whenever you get corrosion like this near your CPU MOSFETs, there's a very good chance that PP bus is going to be shorted to CPU vCore. Now, our CPU wants 1.8 volts. PP bus is 8 volts. So what happens when we short 8 volts to a 1 volt line? It goes pop. It dies. It does not work. So we can do a very simple test to this. So what we're going to do is we're going to put one lead of our meter on one of these inductors right here. So these are our inductors for the CPU, and then another on the PP bus fuse right here. So what we're going to do is put one lead here. Let's grab our meter, and I'm going to put it in view, and it's in some weird mode. What the heck? That's not right. It's in like AC mode when I select a diode mode. Okay, so here we go. Let's switch over to our other views. You guys can see the meter. So here's our meter. One lead on our coil. Now it may beep initially. That's okay. We want to see what it goes up to, and we see we have no short there. Let's check the other one, and I'm also going to reverse the leads. So let's reverse the leads. And we do not have a short. So this is very lucky. This person is very lucky to not have a dead CPU, because when the CPU dies, or when the MOSFET's short to vCore, then it is dead. So before we apply power to see what's going on, we have to take care of this. The ISL I'll keep right now since it's not shorted. It should be okay. So we're just going to take care of these MOSFETs for right now, and then if it comes up later where it crashes in stress test, we may have to replace the ISL 9239. So let's go ahead and take the heatsink coils out, the heatsink screws out, and get to work. Heatsink is off, and now we could have a better look. We could definitely see there's corrosion in this area. Let's add some flux and remove these. This is Amtech NC560 as usual. Got a nice amount of flux there. Let's start to take them off. We're also going to put a little heatsink on the CPU to prevent it from overheating. We don't want to cook our CPU, so we're going to use 430 degrees. As always, that's the temperature I usually like to remove stuff at, so we do not want to overheat our CPU die. There's one. The first one is always going to come off the hardest, but once the area is hot, then all of them should come off fairly easily. Get rid of these caps. And these two over here for our second phase, or our first phase, whatever it is. There's one. There's two. Last one I'll get with the iron, because I don't want to overheat our fan connector and cause it to melt. Because if it melts, it means I have to replace it. I don't want to replace the fan connector because I don't like replacing connectors, period. It's no fun. Still better than replacing a CPU, so. Like that. Now let's start adding some leaded solder. Actually, let's clean this area up with a Q-tip and alcohol. Then add leaded solder, wick it all away. Then we could start replacing the MOSFETs. Let's grab our alcohol. My board is sliding around on the table because there's flux. I don't like that. Doesn't have to be perfectly clean, just somewhat clean. just to get all that junk, all the corrosion out of here, the burn corrosion out of here. That is good to go. Okay, let's add some leaded solder so we could wick all that lead-free stuff away. It's difficult to completely wick all the lead-free away if you don't add leaded solder to it, so that's why we do this. Kind of creates an alloy so the wick can pick it up easier. Just a better way to do it. Let's grab our wick. Solder wick is one of those things that it's always going to hide from you, because you always move it and it disappears. Okay, that should be good enough. Okay. Clean it up again. Clean all the burnt flux away. Add some fresh flux. Let's put some solder on these pads for the so we could solder the new chips on. Should be good enough. Let's go grab some new MOSFETs. Alright, so we're going to take these MOSFETs off a donor board. They don't have to perfectly go into place on the first run, because you're going to be heating that area again, and they will eventually fall into place. And another helpful thing to do is always to check that you don't have a short before turning it on, because sometimes you'll get a bad MOSFET from a donor board. Then if you turn it on, it'll kill your CPU, and nobody wants that. So I'm just going to apply some heat here, so these will fully go into place. It's good to go. Start with these guys. I'm going to turn the board a little bit. Actually, you don't. No, I'm not, because then that would mean I would be heating my CPU. No, I'll turn the board this way. So I'm going to position this board so I don't melt the fan connector. Like this. Perfect. One go into place. Solder these caps over here. Those aren't perfect, they don't have to be. Just add some flux, and we'll flow them into place properly. Surface tension is truly a wonderful thing. There we go. Okay, so now let the board cool a little bit. Then we're going to test and see if we have a short between V-core and PP bus again. Okay, let's go ahead and test between these inductors and PP bus. No short, which is good. No short, do we? Nope. Okay, so we're good to go. Okay, so there's some other obvious issues that we need to take care of before we can turn it on to see if it works. So this is Q7180. This is our inrush limiter for DC in. This is obviously very corroded, and this is going to be no good, I'm sure. So let's take care of this before we try and turn it on, because most likely we wouldn't even get DC in with this in this condition. So put some flux around it, get rid of it, send it on to a better world. This cap looks nasty too, so this is going to go as well. Once it's hot enough, this is kind of in an area of the board that it takes a lot of heat to get off. There we go. Let's clean this up. Wick all the old stuff away. Those resistors are likely fine. Capacitors I'll replace because those can short, but resistors, as long as they're in value and as long as the ends are nice and clean so you can touch them up, they're usually fine. You'll be able to know the difference between a resistor that needs to be replaced and one that's fine. Like if the pad is all gone, then yeah, replace it, but otherwise if they're not, then they're usually fine. You can tell, like if you zoom in, see how the pad is still intact on both those? So those are going to be just fine. There's no reason to replace those. Sometimes you'll see the pad is all red and destroyed, and yeah, don't use those. Don't reuse those. Thinking about upgrading my microscope camera. This one, the exposure seems really low on it, and there's no way to adjust that from settings or anything. So I'm thinking I'm going to look into upgrading to a better one. I have, for the overhead or the face cam, I have a Logitech, which is fine. I mean, nobody watches the channel to see my face, so it's a lousy camera for that's perfectly fine. But the microscope camera would be significantly better. I mean, a upgraded microscope camera. And so that's enough solder there. Let's go ahead and grab our new Q7080 from the donor board. I'm going to put a little flux on the donor board as well, just to help it come off easier. The thermal mass in this area of the board is very high, so it's kind of a pain to take these off. There's a hair under there. It'll burn off. That's okay. And this flew away. Come back. Hate when components fly away. So annoying. This one doesn't have a very good, you can't grip this one very easy, so. Should be good to go. Let me grab a cap in a minute. I'll take care of that cap later. So, let's see. That's gonna have to go too. But PP bus isn't shorted, so it should turn on without that. That's just a reliability concern. This is gross. We're probably not gonna have SMC reset. I'm fairly confident we won't have SMC reset. But let's plug this in and let's see what we get on some rails. So, plug in the fan. Actually, no, I'm not gonna plug in the fan. We know it's not gonna spin. But we'll plug in DC in board. Let's let this cool a little bit more. So, should be good to turn on. I don't see any issues that, I don't see any safety issues that's going to kill the board if we turn it on, at least now. So let's see what we get. The board is cool. Going to check PP bus, vCore. So let's plug it in. Meter, set to DC. And on PP bus, we get nothing. Or less than a volt. DC in, we get 16 volts. Why do we have less than a volt on vCore? Less than a volt on PP bus. Is our vCore... hopefully not. What do we get on ground on vCore? Alright, so resistance to ground on CPU vCore is 4.8 ohms, which is okay. Honestly, for... This is Broadwell. That's a little low. 4.3 ohms. Now what about between vCore and PP bus? Is 16 mil ohms, so we're okay there. The CPU just felt hot because of the heat from the board. Alright, plug it back in. Actually, since we have 1 volt, do we have 1 volt on PP bus? Let's check again on PP bus, so on the fuse. Yeah, less than a volt on PP bus. So let's inspect the circuit that creates PP bus. One, it's going to be this MOSFET here, and secondly, it's going to be this ISL right here. This chip has a little corrosion by it. Let's go ahead and check resistance between. Let's check our current sensing resistance. 20 ohms, we're good. 3 ohms, we're good. So this chip could be bad. This corroded capacitor could have something to do with it. I kind of doubt it. It could be all the junk everywhere. So what I almost want to do, since this board is just so nasty, I kind of want to put in the ultrasonic real quick just to see where we need to focus on, because that'll clean up a lot of the junk that could be causing our issue. So this is going to be my next step. I don't recommend this off the bat, but since we already know we have corrosion here, it's near our, okay, so we have some corrosion by the Thunderbolt circuit, by the backlight circuit. I'm just making a mental note of all this. So we have some by the creation MOSFET for PP bus. That rarely dies though, so we have 18 volts on DC in, so we know our MOSFET is probably okay. All this area is all corroded, so now let's throw it in the ultrasonic just to see, just so we could get a better idea of what's going on and see if it improves anything, because a lot of times when the board is this nasty, you'll get some random issues that the ultrasonic will fix. So let's do that next. Okay, here's our board after ultrasonic. Let's go ahead and take a look at how it looks. So obviously it's much, much cleaner. All the flux is gone. Most of the corrosion is gone, or all the corrosion is gone. Those caps you can see. So whenever they're like this, I'll usually replace them because they're all oxidized and kind of destroyed, but those are corroded. But you can see the board looks much, much better. JTAG is nice and clean. There's evidence of corrosion around the 3v42 circuit, but it's mostly clean. Let's look on the other side. Now this is a red flag to me. So see that? See that chip that's like darkened? That most likely got very hot at one time, so that's got to go. That doesn't look right to me. That looks like it overheated, so that's probably bad. Might even have a short in it. Thunderbolt circuit looks okay. Backlight circuit looks okay. But that had corrosion under it. Evidence of corrosion still under the SMC. ISL area looks okay. Otherwise, it looks pretty decently clean. Let's go ahead and see if it works, because this looks pretty clean. Maybe this will even work. I kind of think this will work after ultrasonic. Okay, so it's a CPU. Our fan is actually plugged in. Let's plug it in. Remember our issue before, we had like 0.9 volts on PP bus or something like that. Let's plug the board in. Grab our meter. Wait for fan spin. I'm going to measure PP bus. And it is 1 volt still, so let me show you guys that it's 1 volt, because I know there's going to be someone that's going to say that it's not really 1 volt. So, meters right here. So whenever we get 1 volt on PP bus, one thing we need to make sure is that PP3V42 is there, because if we don't have voltage on PP3V42, then we're not going to give any voltage on PP bus G3 hot. So I'm going to go ahead and measure this on the coil right here, and that is 3.4 volts. 3.4 volts, so that is present. So now we most likely have an issue in our ISL circuits, either a dead ISL, a short on output, or a dead MOSFET. So let's go ahead and check for a short on output on PP bus first. So switch this back to, I want actually resistance to ground. Alright, so this meter control use sometimes. 65 milliohms to ground, there's no short there. Let's check in continuity mode. Open, yeah, no short. Okay, so we know we had corrosion. If you remember earlier in the video, we had corrosion on our MOSFETs. Let's go back over here to the microscope view. So we had corrosion on our MOSFET for, this is the MOSFET for PP bus. So most likely this is bad and the ISL is bad. So what we can go ahead and do is replace this and replace our ISL 6259. And there was also a little bit of corrosion right here on this cap. I wonder if that cap is shorted. Let me just see. Get rid of this foam stuff, or else it's going to melt. Come on, peel off completely. There we go. Now I can peel it off. It turns into a mess every single time, and it's gross. So this little cap, let's check that guy for a short. Maybe we'll get lucky. Maybe it's just a cap and we don't have to replace the whole ISL. That would be nice. Who are we kidding? I never get lucky. I never get lucky with stuff like this. It's always going to be the most difficult thing. And that is not shorted. Okay. So it is time. You know what? I wonder, could there be a break somewhere that the voltage isn't getting to the ISL for creation? Let's check that. So okay, so 16 volts, 16 volts, 16 volts, 16 volts, 16 volts, 5 volts, normal, 5 volts, normal, 3.3 volts, normal, 1 volt, not normal. Well, it's not working, so alright, so I'm pretty confident our ISL is the issue, so we're going to get rid of that guy, the ISL, and then that other MOSFET. We're going to see if it works after that. So let's start now. Let me turn on my fume extractor. Put some flux down. Don't really need a lot to remove it. Go ahead and do this MOSFET. So what probably happened is this MOSFET actually killed the ISL. Sometimes if the MOSFETs fail, then they can cause the ISL to die. So if they short, like drain or source to gate or something like that, they'll fail. They'll cause the controller to fail too. That's probably what happened in this case. And then a lot of times what we'll see is it'll have 16 volts on PP bus or something, and that's always the ISL of the MOSFET. On one of my first board repairs, what happened was one of the MOSFETs was shorted to ground, so I replaced the MOSFET, turned it on, and it's shorted the MOSFET right away. So I thought, okay, let me replace the ISL on one MOSFET, the one that was shorting, and then the other MOSFET failed, and then I replaced the MOSFETs again, but left the old ISL, and the new ISL killed them both. So it's the best thing, just whenever you have an issue like this, replace the controller and everything it controls. So, or replace everything that output of the controller controls. Like on this case, this is actually 2 transistors in one package. A lot of boards will have 2 transistors instead of just one, but these ones, it's just one. It's a 2 transistor MOSFET integrated into one package. So you only have one to replace. Makes it easier. That's how the Retinas are, or the 13-inch Retinas, the MacBook Airs. The 15 inches are usually 2 MOSFETs. I kind of like the one design better. I honestly see less of the random failures. I don't think I've ever seen a random failure of this type of package compared to a bunch of the other ones that have 2 FETs. So I like this design better, but I think this design can't handle as much current as the other one. That's why they use 2. Let's grab our new chip off the donor board. Come on, little board. Move closer. There we go. Should be good enough. Now the ISL. Actually, do I even need to add? That looks pretty good. There's enough solder on that, so in this case, yeah, we don't even need to add any. It'll be fine with what's on there after we touch it up and stuff, but yeah, that's fine. Should be enough on the center pad too. I don't do that a lot of times, but hey, why not? It'll save about a minute of time. So why not? It's in place. So I'm going to add solder to the edges too when I touch it up right now, so it doesn't really matter. made a bridge. But the bridge is now gone. There's better tips for doing this, that's for sure. That side is fine, so I don't need to worry about it. I messed up that one cap. Let's put that back. Up here, you guys probably can't see it because it's out of frame. What the heck? Why won't that go? That one's like funny. I think I burned it a little bit, but it's fine. Just use the iron. Okay, looks a little third grader, but it'll work. No, who are we kidding? I can't leave that. Make it look nice and pretty. There we go. Alright, so, should work now, hopefully. So, ISL. Should probably wait to turn it on. Nah, who cares? It's probably cool enough. Plug it in. Voltage mode. Okay, I still get less than a volt on PP bus, which is sad. So, wait, I forgot to put back one cap. I don't think that one cap would do it. It might. Let's put back that one cap. Our current sensing was fine. All of our traces are fine. Wait, maybe not. What does this cap even do? Just a decoupling cap that's not going to do it. A lot of times when you get issues like this where it's 1 volt, sometimes the best thing to do is just get rid of all these resistors and stuff around it and put new ones, because sometimes you can get trolled like that because there's some simple issue around it that you can't really see. Let's see, I'm curious now. While the board is cooling down, I'm going to look and see what that one cap does. If it's just decoupling, it's not going to matter. But if it's something else... Okay, it was actually a very important cap. So that's probably why we had no voltage. That was quite important, actually. Okay. Maybe we'll get the fan spin now. Plug it in. Well, maybe we'll get PP bus. Fan spin is asking for a little bit too much. And we still get 1 volt, which is really sad. Okay. So, let's have a look at the circuit. Let's start checking stuff. So, let's open up a schematic for this, this board. It's hard to believe this board was designed in 2014 already. I remember when I started this board was new, and now it's not very new. Oh well. It's hard to believe it's already been 3 years since I started doing this. It feels like a year, or less than that. So here is our schematic. So, see, we could still have an issue with Q7130, but I kind of doubt it. So, this is our U7100 circuit, our ISL circuit. This is our PP bus creation circuit. So, the most common thing to go bad in this circuit is current sensing resistors. So, between pins 17, 18, and 27, 28, you'll get bad current sensing resistors. I already checked those, and those tested fine. I'm going to check them one more time, just in case. I'm going to do that now. Okay, so between pins 27 28, I'll measure at the cap. Wait, we do have an issue, do we? Please tell me I didn't miss this. Nope, 3.8 ohms. 20 ohms, so the current sensing is fine. Okay, so Q7130, this is what was corroded. I initially thought what happened was when this was corroded, it might have killed our ISL. That's not the case because we replaced that. So VDD and VDDP are both going to be our inputs to this chip to work. So this is what the chip needs to work. So if it doesn't get this, it's not going to work. So the first thing right now, what I'm thinking is maybe we have an issue with this resistor. So R7101, we're going to check voltage on both sides. We should get 5.1 volts. So let's do that now. So R70, that was this guy right here. Let's check. That's supposed to be a 4.7 ohm resistor. Let's go ahead and check that. So back over to our microscope. That's this one right here. And that's supposed to be a 4.7 ohm resistor. Let's measure it. 4.8 ohms, perfect. So now let's check voltage. So let's plug the board in, and let's see if we get 5.1 volts on both sides. So plug it in. So 5 volts on both sides, we should get 5.7 volts, that's close enough. 5.1 volts. 5.8 volts, yeah, that's fine, that's intolerance. I don't think there's an issue there. Okay, moving on. So let's go back and have a look at this. So this is going to take charger voltage. So I think there was that one diode, I think D7105 was, yes, so we already checked D7105, we already know this is fine. Our 7105 is another resistor that we checked, and that was also fine. So we kind of know our DC in is getting to the charger now. So when I have seen this before, we've had a few issues, or I've seen a couple of these resistors fail. So if I go through and check every single one of them, it is most likely going to take more time than me just wiping them off the board and starting fresh. So some may argue with this, some may call me an idiot, but I honestly think this is a more efficient way of doing it. So it's these resistors on ACN and stuff. If these go bad, then you will get that 1 volt nonsense. So in this case, what I'm going to do is replace everything around it. Let me just double check something real quick. You know what? Before I do that, let me... Okay, so now my meter is saying I have a short on PP bus, and it wasn't saying that earlier. 0.0 ohms to ground. No, now it's saying 300. Okay, I'm going to plug this in, and I'm going to look at FLIR and see if anything is getting visibly hot on the thermal. So I'm going to do that now. And having a look, I don't see much of anything getting hot. There's one hot spot. Okay, so I may have a short right here. But that doesn't make sense because there's nothing right there. Wait, or is there? Alright, so I'm going to go back over to the overheads. You guys can see what I'm doing. It's probably going to be hard to see because I'm looking at a tiny screen. Let's see if I move that over. Yeah, you guys probably aren't going to be able to see that. But I see a hot spot that I'm a little bit concerned about. If I move it over here. There's a spot that's getting to about 108 degrees. If I put my laser on it, it's right over here, but there's nothing really right there. There's nothing that would be getting hot, and it's definitely hot to the touch. What about on the other side of the board? Ah, it's one of these caps, isn't it? No. I almost wonder if that's internal into the board. Nothing on this side's getting hot. Nothing of concern, I should say. You know, nothing that I wouldn't expect. Oh, never mind, I'm an idiot. That's the screw hole that sees the mat is hotter, so... Okay, so I'm going to go ahead and replace these resistors on the other side of the board. This is going to end up a really long video probably, but it's part of it. You know, we all get long board repairs, so... Switch over to the microscope again. So, if we have an issue in any one of these resistors, you know what? This isn't smart yet. So, I want to try a new Q7180 because Q7180 can do this. And, oh, you know what? I forgot to put back a cap. I wonder if this cap has anything to do with it. I don't think so, but it might. So, let me replace that cap again. Yeah, that may actually be important. Just notice that. Q7180, that should be soldered just fine. So I'm not too concerned there. That current sensing resistor is fine, even though it's just a little bit nasty. Let me put this cap on. I almost wonder if that's the issue right there. If it still doesn't work after this, I may try another Q7180, just because there's a chance that it's dead. Sometimes you'll get those dead from the donor boards. It happens. Let me grab a new cap. Go grab a donor board since the one in front of me doesn't have the one I need on it. Let me just touch this up, just in case. You never know. Maybe it's not soldered on one of the pins underneath. Let this cool down. Okay, so the board should be cooled off now. Plug it in. No fan spin. I'm not expecting the fan to spin. I just want my PP bus voltage to come back. And it's still 1.1 volt. So in this case, what I guess I can do... you know what? It is Q7180. So I got trolled. Let's see. So PPDCN inrush or G3R charger. So PPDCN is 16 volts, but the voltage coming out of my MOSFET here is 1 volt, which is why the ISL is only going to put out what it's giving in, so yeah, that's why it's not working. Yeah, let's just double check. Yeah, this is why it's not working. Okay, so I got trolled. We have a bad Q7180. Let's go ahead and put a new one on. Alright, let's pull this off. You know what? It just wasn't soldered right. I don't think it was even touching those bottom two pads right there. Maybe it was, maybe it wasn't. It's hard to tell. Either way, I'll just try a new one. I'm not going to waste time. So 30-cent chip, if that. Yeah, I'm pretty sure it just wasn't touching those 2 pins right there. But then again, it's hard to say. It could have been just the way I pulled it off too. There's no way of knowing. That's why I'll go ahead and put a new one on. No, come back. There we go. That's pretty good. My microscope, this darn thing keeps going off of... I need to tighten that so it doesn't move. Yeah, it keeps going off to the side so it looks crooked. I hate that. Alright, let's let this cool. But I think that's good. That should be good. So this was another area of corrosion. I gotta take care of that as well. The chip could probably stay, but those components around it have to go. This area, I'm gonna give this area a little flux and heat as well after it cools down. And those caps, right, where were they? They were somewhere around here. Right there, those will go and the chip will get reflowed, but everything else looks fine. This will probably have to go. That can cause posting issues, so that I'll replace. But let's, for the moment of truth, let's see if this works now. Or let's see if at least we get PP bus back, because I'm suspecting that SMC is going to have to be cleaned as well. So we'll know if we get 8.16 volts. No fan spin, but is our voltage 8.60 volts on PP bus? That's what I'm talking about. 8.54 volts now. So that's what that was. Let me show you guys. So, and what's that? That's fan spin. Okay. So you guys know it works. I don't have to show you. However, I can't let this go like this. Yes, it works, but it's not going to last. So, area of concern number 1 is this. So you see this junk right here? Well, that originates from underneath. Look at this. Yeah, so if I leave this, yeah, it's going to work for right now, but in a couple months, it's not going to work. So I got to take care of this. Just get rid of this edge bonding. Give this chip a nice little reflow. Clean out all that corrosion underneath. And yes, the ultrasonic does that part way, but it does not get rid of the... It doesn't... if there's anything under the solder joints, you know, when solder joints get all nasty from corrosion, the ultrasonic won't fix that. These actually rarely die from liquid. You'll probably get 1 in 10 that die from liquid compared to, you know, out of 10 liquid damaged chips, you'll probably only get one that is dead. The rest just need cleaning. Because it handles all low voltage, so you can't really, it's kind of hard to kill with low voltage like this. When everything is 3-volt data lines, it's kind of hard to kill something like that. It just makes it not work if there's corrosion under it. And yes, I'll be ultrasonicking this again. But it was kind of nice to get rid of that first batch of junk on it so we could work on it. Actually thinking of not replacing the LP8550 as well, because those aren't going to be available soon. I think I actually bought the last of the stock in the US. So I kind of want to avoid replacing these guys when I can, so I'm probably just going to give this a little flux. Actually, you know what? No, I can't do that. Look at this. No, maybe I can. Let's look at it. Yeah, you know what? We'll give it a little flux and test it and see what it does. You never know. Maybe we'll get lucky and it won't need to be replaced, because that means I could save a chip, and like I said, these aren't going to be available soon enough, and I want to preserve them of what of the couple hundred that I have, so, or 100 that I have. I forget how many I have. I have like 140. The chances of it dying after it's cleaned like that is close to nothing, so we should be good. That's fine, honestly. What was left? So these caps right here. And that was about it, I think. Wait, the Thunderbolt chip. So the Thunderbolt chip has to go, this has to go. Just mark it with the flux so I don't forget about it. Yeah, that looks burnt. That would not be good of me to leave that on without replacing this. Thunderbolt fails in a really, really fun way, too. A very violent way when it fails, so it's good to keep that out of there. My wick fell. Could leave this off. I mean, who uses a Thunderbolt device with a MacBook Air? But I won't do that. I've only had one person get upset about having no Thunderbolt. It's like, what can I say? It's either this or you have to spend more to get your board replaced because it exploded and now you have a working laptop. And they probably didn't use that port until I said it wouldn't work. So yeah, that's usually how stuff like that works, is they don't use it until you tell them it's no good, then they want to use it. And a lot of people, they just want to find something to pick on. That's why we go by the 3 strikes policy here. You get 3 calls for updates. So strike 1, that's 1 call for updates. Strike 2, 2 calls for updates. And strike 3, on the 3rd call, that's your last and final call. And then you get your device sent back. Usually that occurs in like 2 days time frame. I really wish more people would get that coming across rude isn't going to get you anywhere. Like if I have, let's say I have 2 devices in my immediate queue. Whose do you think I'm going to fix first? The one guy that is being a complete jerk to me and low-key insulting me, or the customer that's being very appreciative and really happy that I'm helping them. I'm gonna go for the one that's being appreciative and nice to me. And then after I'm done with everything else, then I'll work on the guy that's being extremely rude to me, his computer. I really don't understand that mentality. I've said this a million times in my streams and videos, but I seriously just do not understand being rude to somebody that's trying to help you. I guess some people are just extremely miserable, but then again, that's not even an excuse. I mean, I haven't been the happiest in my life, and yet I don't act like that towards people. At least I don't think I do. Maybe I do. But I don't know. Just some people are in their nature to be rude. Okay, that's good enough. Let's go ahead and put these caps back. If there's one part of liquid damage repairs that I hate, it's this. It's the rebuilding stuff. I really hate that. I like the one corroded component, then you're done. I don't like this replace 500 things on the board to fix it kind of thing. But it's part of it, so I will do it. Yeah, that little guy right there can cause posting issues. Don't get trolled by that. If there's any corrosion by that, replace it. Getting trolled by something that's right in front of your face, like that Q7180 earlier in the video, is like one of the worst things. You don't want that to happen to you. It's gonna happen from time to time, but why not avoid it if we can? Last step is gonna be these guys over here. Wait, the backlight fuse has a backlight fuse. Okay, I can't leave that backlight fuse. That's not gonna work either. So a little bit more work. Yeah, I really don't like jobs like this, where it just rebuilds stuff. It's just not fun. A lot of shops will just send this out. Yeah, it works. Send it back. But I don't like doing that because it's not, you know, I have a long warranty, and this causes it to come back in warranty, and that's not what I want. Because ideally, if you're bringing me something back that I've worked on, it means it doesn't work. So for most end user customers that only have one MacBook, I'll only like to see them once. Because if they come back, that usually means there's an issue with something. Unless you're bringing me something else, that's different. But generally, I only like to see you once, so. That cap's gotta go. It's fine. This fuse is trash. I'll use my hot air on that. So this one, and these guys. So all of these components will also go. The chip is fine. As long as the chip works, then that's going to be fine. But this stuff I don't trust. A little bit of a longer video than I expected or wanted, but oh well. Eventually you just get a feel of what's going to fail or not on the board, so you just learn to judge what you can leave and what not over time. Certain chips I'll replace if they're corroded, certain ones I wouldn't. Before I used to replace, if anything had any corrosion on it, I would just replace it. However, that's not really necessary, because it's oftentimes fine. This is kind of yucky because it's like all destroyed on the pad. Guess it's not too bad, but I don't like it. I know it's hard to see for the glare, but just gonna use my iron, kind of scrape away at that nonsense. That should be good. Come on, go upright. Little fuse, bad little fuse. Come back. There we go. Don't run away. I know, you don't want to be on a MacBook, but oh well. we go. Last cap right here. Actually, this one too. I don't trust this one. I'll touch up these pins too on the backlight for backlight on the LVDS. They're a little bit corroded. They're not too bad, but I'd prefer to take care of those. That's much better. Okay, I think we're good to test now. So I'm going to put this back in the enclosure, and then we're going to see if this works again. Hopefully, everything will be good. Hopefully, it'll work fine. Hopefully, we won't have no backlight or some nonsense like that, but I think we should be alright. Alright, so just turned it on. It's currently booting up, I think. The light on the screen is lit. So I'm just waiting for that question mark folder to come across the screen. Should come up in a minute. The heatsink is off, the trackpad isn't plugged in, so it's going to be a little bit slow. But I'm going to lean this up like this. There you go. So, another MacBook fixed successfully. So, this is a little bit of a long one. It was kind of a pain, but it's fixed. So, thank you for watching, and I hope this video helps you some way with solve your issue.